All right, we're going to wrap up Chapter 8 here by solving multi-step equations. Nothing really new we're going to run into. We're just going to kind of combine everything we've learned in Chapter 8 about solving equations and inequalities into equations that might need to use all of the skills that we've learned. So when solving more complex equations, please keep these three key ideas in mind. The first thing we want to do is simplify each side of the equation. That means eliminating any parentheses, combining like terms, etc. Just try to simplify each side of the equation before we start dealing with things. And then if there are any variables left on both sides of the equation, we're going to eliminate one of them. Remember, pick on the little guy. We're going to eliminate the term that has the smaller coefficient. And then finally, solve the resulting equation. It should now be a one or a two-step equation. So it really comes down to just that basic skill of solving one and two-step equations, and then we're just going to take these more complex equations and kind of chisel them down into one or two-step equations. So let's take a look at an example here. 12m plus 12 equals 6 times 3m plus 3. So we've got a lot of things going on here. We've got parentheses and we've got variables on both sides. So the first thing we're going to do is try to simplify this right-hand side of the equation by getting rid of the parentheses. And I'm going to use the distributive property to do that. So the left-hand side is going to remain unchanged. That's 12m plus 12, and that's going to equal 18m plus 18. Now the parentheses are gone, but I have variables on both sides of the equation still. So I'm going to pick on the little guy, which is my 12m. So I'm going to subtract 12m from both sides of my equation. And that gives me 0 plus 12 on the left-hand side, which is 12. And 18m minus 12m is 6m plus 18. So now that I've done that, now I'm down to my two-step equation that I can solve. I'm going to get rid of this constant, subtract 18 from both sides, and I get negative 6 equals 6m. One more step, get rid of that coefficient by dividing by 6. Negative 6 divided by 6 is negative 1 equals m, and we're solved. So really we're employing all of the skills that we've learned into one more complex equation. So just take it one step at a time and keep chiseling that thing down towards the solution. Here again, we've got variables on both sides and we've got parentheses on both sides. So again, I'm going to use the distributive property to get rid of these parentheses. So I can start working with my terms. This gives me 5n minus 15 equals 3n plus 21. And then I'm going to eliminate the term on the right-hand side. This is my little guy, 3n. So I'm going to subtract 3n from both sides. And I get 2n minus 15 equals 21. Now again, here we go. Two-step equation. Add 15 to both sides. And I get 2n equals 36. Divide both sides by 2. N equals 18, and solved. So again, getting rid of parentheses, getting rid of terms that have variables on both sides, and then solving the one or two-step equation. Here we've got parentheses on the left-hand side, we've got variables on both sides, and now the right-hand side is not simplified. So lots of things going on here. So I'm going to simplify the left-hand side by using the distributive property. Negative 6r minus 8 equals, and then I've got on the right-hand side, I've got some like terms here. Negative 5r minus r is negative 6r minus 8. And you might notice something's odd here. We get the exact same thing on both sides of the equation. Negative 6r minus 8 equals negative 6r minus 8. Well, if you didn't notice that, you would probably be looking to eliminate the term with the variable in it, but they're the same thing. So if you try to eliminate that by adding 6r to both sides, you'll notice that all the r's go away. And this is 0 minus 8, which is negative 8. And this is 0 minus 8, which is negative 8. You get a true statement. Negative 8 equals negative 8. Well, no duh. Well, what happens when you run into this situation where both of your variables disappear and there's nothing left to work with? Sometimes when solving an equation, both of the variables are eliminated and all you're left with is a true statement. When this happens, we call this the identity, or all numbers are solutions. Okay, so the identity is an equation that is true for every value of the variable. Every number we pick, every number we pick will be a solution to this equation. No matter what you put in for R, it will be true. So this is what we call all numbers, or the identity. Or we can even say there are infinitely many solutions to this equation. There isn't just one solution. Every number is a solution. We call that the identity. Let's take a look at this one. Again, I've got parentheses on the right-hand side. I've got variables on both sides. My left-hand side is not going to change, but the right-hand side, I need to use the distributive property, and that gives me 32 plus 8w. And again, I run into a situation where I don't have the identical things on both sides of the equation, but I do have the same coefficient. So if I try to eliminate one of these by subtracting 8w, I actually end up eliminating both of them, and I end up with 14 equals 32, which is a false statement. That's not true at all. So now the same thing has happened, but I've ended with a false statement instead of a true statement. What am I going to do with this situation? Sometimes when solving an equation, both of the variables are eliminated and all you're left with is a false statement. When this happens, we call this the null set, empty set, or no solution. And the null or the empty set is equations that have no solution. And then I've got a couple of math symbols here. This kind of a circle with a line through it is the symbol for the null set, and then the empty braces is the symbol for the empty set. There is no number that will ever make this equation true. So we would say no solution, or null set. We cannot solve that equation. So that's equations. Now let's look at inequalities, and we'll see that it's very similar concepts. When we're solving more complex inequalities, keep the same things in mind. We want to simplify each side of the inequality, eliminate parentheses, combining like terms, etc. And if there are variables on both sides, we're going to eliminate one of them by picking on the little guy, and then solve the resulting inequality. It should now be a one-step or a two-step inequality. But remember to reverse the inequality when multiplying or dividing both sides by a negative. We cannot forget that step. If you multiply or divide both sides by a negative number, you have to reverse the inequality symbol around. So let's take a look at some examples of solving inequalities here. Here I've got parentheses on the right-hand side, so I'm going to go ahead and get rid of those using the distributive property. 3 is less than 4x plus 8. And now it's a two-step inequality. I can solve this. I'm going to subtract 8 from both sides. I get negative 5 is less than 4x, and I'm going to solve by dividing by 4. Notice I'm dividing by a positive number, so I am not going to switch my inequality symbol around. This is negative 1 1/4 is less than x. And then again, remember, we can reverse that to write it with the variable on the left-hand side. X is greater than negative 1 1/4. So either one of those ways to express that solution to the inequality. So again, solving inequalities, very similar to solving equations. Next one, again, very similar. I'm going to use the distributive property to get rid of my parentheses. 4b minus 12 is less than or equal to 72. Two-step inequality, get rid of the constant, add 12 to both sides. I'm left with 4b is less than or equal to 84. And again, I'm going to solve by dividing both sides by 4. I'm dividing by a positive. The inequality is not going to switch. B is less than or equal to 21. And there's our solution there. Next, we've got a little more complex one. And then again, a reminder, do not reverse the inequality sign. Just because there's a negative sign in the inequality, only reverse the sign if we multiply or divide both sides by a negative number. So keep that in mind before you panic when you see a negative number in an inequality. Going to get rid of the parentheses here. Again, using the distributive property, negative 2k minus 2 is greater than negative 16 plus 5k. And now I have variables on both sides of this inequality, so I am going to pick on the little guy, which is my negative 2k. So I'm going to add 2k to both sides. This does not affect my inequality symbol at all. I have 0 minus 2, which is negative 2 on the right-hand side, is greater than negative 16 plus 7k. And then I have to get rid of this constant. Now I have a two-step inequality. I'm going to add 16 to both sides. And I get 14, positive 14 is greater than 7k. And then one last step, divide both sides by 7. and that gives me 2 is greater than k. And again, I can reverse that. K is less than 2. Either way, they mean the same thing. Solving that one, so there we saw an inequality that had variables on both sides. And then here we've got an inequality that's got variables on both sides and parentheses involved. So I am going to, again, get rid of the parentheses using the distributive property. 2p plus 5 is greater than or equal to 3p minus 18. And I'm going to pick on the little guy, which is my 2p's. I'm going to subtract that from both sides of my inequality. Again, the inequality symbol is unaffected. Left-hand side, 0 plus 5 is 5, is greater than or equal to p minus 18. And then I just have to add 18 to both sides to eliminate that constant. 5 plus 18 is 23, is greater than or equal to p. Or, again, if I want to write that with a variable on the left-hand side, p is less than or equal to 23. So solving those, very similar to solving the equations. Just keep in mind that we've got the tools and the ability to solve very complex equations. We just have to take it one step at a time and try to get that narrowed down to a 1 or 2 step equation or inequality so we can solve them more easily.